So one of the things that always comes up in any kind of model fitting is overfitting. That is, are you trying to fit more parameters than can be justified by the data? One really nice way to decide if you're overfitting is using something called an AIC information criterion, which basically penalizes fits that get better because they add more parameters that fit stochastic variation in the data rather than a real signal. And so that's implemented in pytc, and I'm going to show you how to do that. So what I've done here is loaded a simple single site binding experiment, and what we're going to ask is whether or not we are justified in including a fraction competent term. That's going to basically say that some fraction of our molecules aren't competent. It's kind of a slush term in the fit. So what we're going to do is go up here to this thing called AIC test, and what we're going to do is do a fit where we float our fraction competent term, and then we're going to repeat a fit where we fix that term and ask whether or not we're justified in including that floating term. So the first thing we're going to do now is we're going to actually do our fit. And once we've done that fit, we're going to hit append new fit, and that's going to append this fit where we floated this fraction competent to the AIC tester. Our next step is to go to our fit itself, and we're going to repeat the fit, but this time we're going to fix our fraction competent to a value of 1 and redo the fit. So now we've redone the fit. Notice it's not a very good fit anymore. If you were to look at the residuals, they're much higher, they're much less random. So we would already look at that and say, whoa, that was bad news, but we can show statistically that we should include that parameter. And we're going to give this fit the name fixed. And if we wanted to test between multiple models, we could just keep doing this. We could keep appending fits here, but we're just going to do 2 for now. We're going to select float and fix the 2 models, and we're going to perform our AIC test. And this is the result that comes out. So this performs actually 3 related tests: an AIC, a corrected AIC, and something called a BIC, or Bayesian Information Criterion test. And then for each model, it spits out the relative weight. That's the probability that this model minimizes the information loss relative to the other models in sort of statistical terms. But basically, we can think about this as this is the support for whether or not we should use the float model or the fixed model. And these values basically all strongly support float. All of the probability of minimizing the information loss is set on the float for all 3 of these tests. And so we would find this strong evidence that we should include a floating fraction competent parameter. So you can imagine doing this for any number of different parameters that you want to estimate, but using this flexible framework, you should be able to do it as you need.